Hello, my name is Amna Mehboob, and today I'm going to walk you through my solution for the Kaggle competition that I took place in. It's called House Prices Advanced Regression Techniques. Here you can see the submission and my rank as well. This is my notebooks working. This is the output, right? Let me scroll up to show you the working that I did. I basically applied 3 machine learning models, and then I evaluated their accuracy using the metric root mean squared error. But before that, I applied some data preprocessing techniques like one hot code encoder, and I also did some data analysis, as you can see in these diagrams. Now, the goals of these projects was basically 2. So the first one was they were actually over 80 features within the dataset, but I narrowed down the search to only 4 of them, right? So from the selected features, I wanted to see the correlation, the relationship, and the trends that it had with the sale price, right? Which was our target value. Then we wanted to test various machine learning models, right? And we wanted to see their accuracy by using the root mean squared metric. The steps that I took was basically I defined the problem, then I performed some data cleaning techniques, making sure that the data set itself, it had no null values, and any string-based columns were, transformed into other columns, that had zeros and ones according to the presence. If it was present within the data set, within the row, then it would be 1, right? And then we applied some data analysis to get familiar with the data set a bit more. And finally, we applied some model selection, evaluation, and then I created a presentation to summarize my findings. As you can see here in the feature selection and correlation, right? So the 4 features that I selected was year sold, month sold, and overall house quality, as well as house condition. So I created a heat map, right? So the way to understand a heat map is by looking at the range. So if it's 1, it means that it has a positive correlation. If it's 0, it means that it has no correlation. And if it's below 0, it has a negative correlation. Now, other than the house quality against the sale price, it was the only feature that had a positive correlation, right, with a 0.3. The rest of the features, unfortunately, were negligible because their value was a lot less than 0.5. Now, I created some scatterplot diagrams to show us the relationship between the sale price and each feature itself. Like, for example, in the year sold, we can see that within 2016 to 2010, we can see that the house prices, they decreased, right? Here it was higher the range, here it became lower. It dropped to approximately 50,000 to 40,000, right? And we can also see that very few houses were sold above 50K, right? And as the year increased, the house pricing, according to this data set, it decreased. Now we can see in the month sold that the month 7 was the one that sold the most, right? So we can see that seasonally, technically, in the beginning of the year, we can see a lot more houses were sold, a lot more pricier ones were also sold. And as the month goes on, the prices fluctuate, right? And in the end of the month, which is 12, the prices of the houses, they decrease. Here we can see the overall condition. We can see that if most of the houses bought, regardless of whether they were pricey or not, were in their ranking of 5, right? So we basically gave the condition and the quality feature, we gave them a ranking of 1 to 9. So if it ranked 9, it was sold the most. And if the quality was 10, then it was sold the most and it was pricier. Now we can see some of the trends. We can see that in this graph that I'm pointing at right now, it's the average sales per year, right? And we can see that overall, the houses were sold quite a lot in average, right? And a lot of houses were bought in 2009 and 2010. And we can see in the average sales per month, right, that at the end of the year, pricier houses were sold more. And then we can see in this graph, the average sales by house quality. We can see that most of the houses that were sold had a quality of 10. And in the overall condition graph, we can see that most of the houses sold were once again of the highest condition and highest quality. Now, the 3 learning machine models that I applied was linear regressor, right? And the root mean squared error is this value. Then we applied XGB boost regressor. Here it is its root mean squared value. It had the highest accuracy. And finally, we applied random forest regressor, right? Finally, we can see a graph that was made using the machine learning models. In the orange line, we can see that the predictor values were actually lower than the original values, right? And that is it for this presentation. Thank you so much. Bye.